So in the EG method, when you have a face and it's a diagonal face, then you would do an EG2 algorithm to solve the rest of the cube. But before learning the EG2 algorithms, you should actually know how anti-CLL works, which is an alternative to EG2. So anti-CLL is basically just recognizing CLLs, but in a different way. So this case here, this T case on a diagonal face, you would, for anti-CLL, you would solve this case by doing this CLL algorithm. So that would look like this. And then that gives you the Ortega 3 mover, which can be done with R2, F2, R2, and with a lot of other ways to solve that case. So I'll show an example of an anti-CLL recognition. So this soon case, you can see that these two stickers are the same and these two are not. But if we go to this CLL case, these two are opposite and these two are not. So basically, if you see like stickers that are the same or opposite of each other, pretend that the two stickers that are the same, pretend that they're opposite, and then just see what case you would get. In this case, you would just get soon. So you solve this case with soon, and then R2, F2, R2. So I'll show an example of an anti-CLL recognition. So this soon case, you can see that these two stickers are the same and these two are not. But if we go to this CLL case, these two are opposite and these two are not. So basically, if you see like stickers that are the same or opposite of each other, pretend that the two stickers that are the same, pretend that they're opposite, and then just see what case you would get. In this case, you would just get soon. So you solve this case with soon, and then R2, F2, R2. So another example is this. We can see that these two are the same and these two are opposite. So now we just imagine that these two are opposite and these two are actually the same, and we actually get this case, which we solve like this. So you would just do that same algorithm, and then it gives you R2, F2, R2. So this example, this one might seem a little confusing at first, but basically, so we see that there's two bars here, these two are the same, and these two are also the same. But the algorithm that we need to do to set up into R2, F2, R2 is this case where these two are opposite and these two are opposite. So you can pretend that the bars are just opposite colors and we get this case. And the R2, F2, R2. So the H cases, specifically this one and another one, which I'll explain later, they don't actually use different case like algorithms. They'll use different algorithms. It's actually just the same algorithm, but from a different angle. So these two are the same and these two are opposite. So you would pretend that these two are the same and these two are opposite, which means that you just hold it like this, then do the algorithm, and then it gives you R2, F2, R2. And again, for this case, you would pretend that these two are the same and these two are opposites. So these two are the same. So what you always do is you hold the same stickers like that and then do the algorithm. So if these are the same, then you do the algorithm from here, and then R2, F2, R2. So now it's important to know the different ways to solve the 3-mover. So the first one is obviously R2, F2, R2, but you can also do R2, B2, R2, and that's really useful for a lot of cancellations. And another one is F2, R2, B2, or B2, R2, F2. Or if you're facing this way, you can do U2, R2, U2. So an example of the way you can cancel into the 3-mover. So we have the soon case, and then instead of just doing soon, you can see that we end with the R prime, and then we do R2, F2, R2, or we can do R2, B2, R2, but we can cancel into R2, B2, R2, and that would look like this. So in this case, we pretend that these two are the same, and that gives us this case. So that's just F sexy F prime. So F sexy F prime, except we end with the F prime. So instead of doing F prime, we can actually just do F, which cancels into F2, R2, B2. Now for predicting AUF, if all the bars are solved like this, then there will be no AUF. And then you can, this is a U prime AUF, because if we look over here, green goes to here and green is over here. So it's U prime AUF. And then U AUF. This goes to here because this is red, and then red needs to go to here, so it's a U AUF. And then a U2 AUF is just a checkerboard pattern, and like these are all opposites. So I won't go over every single anti-CLL case, but if you want, but to practice it and to like learn which algorithms you need to do, just so this is a T anti-CLL, and then this is a T and then CLL case. So you would just do all the T cases. So these are the exact same case, but this one's EG2 and this one's CLL. So you would just do like all of the T cases until one of them gives you a diagonal swap, and that's how you know to do that algorithm, and it sets up to R2, F2, R2. Anyways, that's it for this video. Thanks for watching, and I'll see you guys next time.